Hello, I'm here to invite you to watch an animation to bring you hope regarding a serious and potentially scary subject, cancer. I'm Dr. John, a retired MD and also a cancer survivor. The animation is based on the conclusions I published in this book, Surviving Cancer. And I'll be back after you see the video.
The word cancer raises fear in all of us because cancer is a state of uncontrolled cell multiplication that eventually takes over your body. But how does this happen? To understand cancer, we need to understand the workings of a cell. Each cell in any living organism is an independent unit, even when they look different and function differently. Inside every cell, except mature red blood cells, is the nucleus, the control center for the cell. Regardless of the cell type, the nucleus in every cell has 23 pairs of chromosomes, one half from the mother and the other half from the father. From the moment of conception, when a sperm cell meets up with the egg cell and merges, the 23 half sets of chromosomes pair up with their corresponding ones. Each chromosome is a long coiled-up chain of deoxynucleic acid, or DNA, in double helix shape. Groups of DNA form genes, and there are thousands of genes in a chromosome. Each gene governs the function or definition of some aspect of your being: your gender, your skin color, hair color, eye color, height, bone structure, and so on. What's interesting is that every gene has a duplicate, a backup, just in case something goes wrong with one of the genes in every pair. Your cells divide as your body grows or needs new cells for repair and replacement. But how does this happen? There's a gene called the growth activating gene that initiates the process. Then, when enough cells have been created to repair the organ or replace dying cells, there's another gene called the growth inhibiting gene that sends out a signal in each cell that is multiplying to stop the process. Each time a cell divides, it must duplicate genes for the daughter cell. It does this usually within a few hours. This opens the door to accidents occurring in any one of thousands of genes that must duplicate themselves. Each accident is called a mutation. Beneficial mutations have been preserved, leading to evolution, and this allowed humans to separate from chimpanzees and become intelligent Homo sapiens in a period of a few 100,000 years. In addition to accidents that occur when the cell divides, mutations can result from things like exposure to UV light, ionizing radiation from the sun, radioactive elements and X-rays, or from reactive chemicals in the environment from industry or ingested in foods we eat, or from oxidative damage from oxygen radicals released during aerobic metabolism inside the cell. Some mutations may cause a gene to malfunction. However, nature has mechanisms capable of preventing a cell with mutations from becoming a problem. One mechanism is where cells identify and repair the dysfunctional gene. If that can't be done, another mechanism destroys the cell before it multiplies again. This process is called apoptosis. In the third mechanism, an army of natural killer cells in your immune system can identify and destroy these cells. The fact is, adults develop mutated cells many times during their lifetimes and are almost always repaired or destroyed. With all these safeguards in place, what causes cancer to take hold in people? As you saw, we have 2 genes for cell growth activation. We also have 2 genes for cell growth inhibition. Let's say that there's a mutation of one of the growth inhibiting genes. Fortunately, your backup growth inhibiting gene number 2 will prevent the cell from dividing endlessly. But if both growth inhibiting genes are mutated, there is no gene to stop cell multiplication. In the vast majority of cancers in adults, the cancer cells keep dividing because both growth inhibiting genes are mutated. How does this uncontrollable and overwhelming multiplication of cancer cells occur? This explanation is a key to surviving cancer. As we said, a mutation on both growth-inhibiting genes gives the cell the chance to multiply. But in order to actually multiply, a cancer cell needs energy, construction materials, and a growth promoter. Regarding the energy, for the vast majority of cells in the body, glucose serves as one of two fuel sources to produce adenosine triphosphate, ATP, the energy needed for the cell's metabolic activities. But for cancer cells, glucose is their primary fuel. So when they have lots of glucose, cancer cells thrive. As for the construction materials, cancer cells also use glucose molecules, not only to produce ATP, but also to create raw materials needed to construct the new cells. As for a growth promoter, when the glucose level in the blood is elevated, the pancreas releases insulin. In a normal cell, insulin facilitates the entry of glucose into the cell. However, cancer cells have special transporters to capture the glucose without help from insulin. In normal cells, insulin also helps the workers called enzymes inside the cells to extract energy from glucose and use materials to fabricate everything needed, including a new cell. But in cancer cells, insulin makes these workers work even faster. In other words, insulin acts as a cell growth promoter. Why is understanding this important? Because it tells us that cancer cells benefit from high levels of glucose and insulin. It means that a cancer cell, whether newly created by a mutation or a cell that escaped destruction after treatment, if you are a cancer survivor, will very likely keep multiplying in the presence of glucose and insulin. As you can see, the more persistent the level of glucose and insulin in the body, the faster cancer cells multiply. This rapid growth often helps multiple cancer cells detach themselves from their mass and migrate to other parts of the body to start new colonies. In most cases of cancer, it is not the uncontrolled multiplication, but metastasizing, the spreading of cancer to another part of the body, that is the major cause of cancer-related death. All it takes is for one cancer cell from a tumor to break free and enter the bloodstream and settle in some other part of the body for cancer to spread. Most are destroyed by killer cells, but just one can start a colony elsewhere in the body. No matter where a cancer is located, it is not good news for the cells around it. This is not because cancer cells release toxins that harm other cells, nor do they attack their neighboring cells. The way cancer causes death is by disrupting the function of the normal cells around them and robbing them of their needed nutrients. The normal cells cannot survive without their nutrients. Moreover, if your body has multiple cancer sites due to metastasis, it is nearly impossible for your immune system to keep up and kill the cancer cells that begin populating several of your organs. This colonization of many parts of the body by cancer cells is what ultimately causes death. It should be obvious what you have to do to survive cancer. Prevent the cancer from spreading. If you can keep the cancer at just one location, your body has a fighting chance of defeating it. So now the question is, how can you prevent a cancer from spreading? My answer is that you need to starve the cancer cells of their primary source of energy and construction materials, glucose, before the cancer cells starve the normal cells around them. And the way to starve cancer cells of glucose is to reduce your intake of complex carbohydrates, such as grains, the food that produces the most amount of glucose in the body after digestion. I'm talking about wheat, corn, rice, and other common grains that we tend to consume at every meal. The fact is, our modern diets full of grains provide an ample supply of glucose that cancer cells need to survive. In effect, when we consume breads, cereals, muffins, donuts, pizza, cakes, pasta, and snack foods, cancer cells will multiply with increasing speed. About 100 years ago, grains and grain flour products constituted less than 30% of the daily energy intake for most adults in the world. Today, however, the daily intake of grain-based energy is about 50% in developed countries and 70% in developing countries, thanks to the agricultural revolution and government policies making food from grains or grain flour cheaper. This increase in consumption of grain-based foods parallels the increase in cancer incidence all over the world. There's no other credible association with any known cancer-causing or cancer-promoting agents to explain this worldwide increase in the incidence of cancer. Only our diet of grains can explain why cancer rates are increasing around the world. My message is this: there are good chances that you can survive a cancer confined to one location and not spread to other parts of the body by reducing your intake of grain and grain flour-based foods to less than 30% of your daily food energy intake. If you're getting treatment for cancer, such as chemotherapy, but you are eating a usual diet containing a lot of grains, such as bread, pizza, muffins, tortillas, flatbread, rice, and corn, you are essentially feeding cancer cells on the one hand while trying to kill them on the other. And if you are a type 2 diabetic injecting insulin, be aware that you must take special precautions even if you do not have cancer. This is because insulin injections can amplify the growth impact that insulin has on cancer cells. Here's why. In a healthy person, the pancreas releases two hormones, insulin and glucagon, to control the level of blood sugar. The insulin is released in a pulsating fashion in response to elevated glucose level until the pancreas senses the need to release glucagon to balance out the insulin. However, in a diabetic who is injecting insulin, especially long-acting insulin, or is taking medications that cause the continuous release of insulin in the body, there is no balancing out of the two hormones, insulin and glucagon. The constant high levels of insulin in the body could therefore stimulate cancer to grow faster than it would otherwise. High blood sugar and high insulin levels, along with injecting insulin, these explain why having diabetes significantly increases the risk of liver, pancreatic, endometrial, colorectal, breast, and bladder cancer. Statistics show a clear correlation between having diabetes and these types of cancer. So, if you are diabetic, starting today, your objective should be to lower your dose of insulin and/or medications that cause release of insulin within your body. The good news is that you can accomplish this by lowering your blood sugar and by avoiding grains and grain-based foods.
Now that you have seen the video, I want to show you the strategy to win your fight against cancer. That and more information is presented in this book, Surviving Cancer, that contains a new perspective on cancer itself. I wish you well. Thank you.